Hi there. Today we're going to start talking about sequences. So right here, if you look at your sequence notes that you should have picked up on the way in, at the top it gives a definition. A sequence is any set of numbers or objects that can be put into a one-to-one correspondence with the positive integers 1, 2, 3, 4, 5, etc. n minus 1, n. These are your terms. That's what these are. And this will just continue counting using positive integers. So it says, thus a sequence is a function whose domain is the set of the positive integers. Okay. If you'd like to have the substitute, pause it right now, and you can try to fill these in if you want to try to recognize the patterns. I'm going to go ahead and go through them now. The first one, 5, 11, 17. The pattern is adding 6 each time. So then you would have 35. You have an ellipsis there, which the dot, 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 which means that this would continue. So this would be an infinite sequence. Now this is, it's arithmetic if it's adding the same number every time. It's geometric if it's multiplying or dividing the same number every time. So since this sequence is adding 6 every time, this would be arithmetic. Spelt like arithmetic, but if you're describing, if you're using it as an adjective, it's arithmetic. Okay, the next one, 81, 27, 9, 3, dividing by 3 every time. So let's see, that would be 1, and then this would be 1/3. Now this one, it stops at 1/3, so that would be a finite sequence. And that one's geometric. 1, 1, 2, 3, 5, 8, 13, 21, 34. You may have seen this before. This is known as the Fibonacci sequence. Fibonacci. Really cool. You can find Fibonacci sequence in nature and all kinds of plants and different things around the world. But what's happening here, it's adding the 2 previous terms. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. So this would be 21 plus 34 is 55, would be the next term there. That one's infinite, and it is neither arithmetic or geometric. This one's kind of mean. January, February, March, April, May, June, July, August. It can be infinite because it can repeat. And then neither arithmetic or geometric. Let's see, this one here would be 4. This is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. This would be finite because there's no ellipses there. Neither arithmetic nor geometric. Okay. If we were going to add another term here, looks like I left that off. Let's see. It's adding 2 every time, but it's changing signs. So this would be a negative 13. This one's just multiplying by a negative 1 every time. And it says that it's infinite. So that would be geometric. Multiplying by negative 1. And then this is really random, but these were it's from a couple years ago actually, but these were the the number 1 seed of the March Madness tournament, number 2 seed, number 3 seed, number 4 seed. These were their scores in the opening round of March Madness. So this would still be considered a sequence because we can put a one-to-one correspondence to these scores. So that would be finite, neither arithmetic nor geometric. So there's no real pattern there. See if you can create a general formula for the 5th sequence above. So if you look up here, the 5th one is the 1, 4, 9, 16, 25. So if you think of just n being the number of terms, so when I plug in a 1, I get 1. When I plug in a 2, I get 4. When I plug in a 3, I get 9, and so on. So this would be the nth term, is how we say that. A sub n would be the nth term. So if we're going to write that as a formula, you would say the nth term is equal to n squared. So what we can use this for, this formula, I can use this formula and I can find any term. So if I wanted the 10th term, I wouldn't have to continue that sequence. I could just plug it into the formula and I would get 100. Okay. So again, this right here is the nth term. Is how we say that. And also this formula right here, if you go down to the next section where it starts talking about the different types of formulas, this would be considered an explicit formula. So look at the definition of explicit formula. An explicit formula is a formula that gives the nth term, that's what we found right there, the nth term, as a function of n. Okay, so this guy right here would look something like that. There's another type of formula that we'll talk a little bit about. It's called a recursive formula. A recursive formula is a formula that gives the first term or the first few terms and then defines the nth term using the previous term or few previous terms. So, for example, let's go back to that Fibonacci sequence. Let's see here. A1 was 1. The second term was also 1. The third term was 2. How did we get to? We added the 2 previous terms. So we can write that as a recursive formula using the previous terms to show that. We would say that, let's see, the best way to say that is, I didn't have to write that, but we can say A1 is 1, A2 is also 1, and then we would write the formula. We would say that A sub n is the A sub n minus 2, so that would be 2 terms before, plus 1 previous term. So all of that, listing out the first term, listing out the second term, and then that formula, that would all be needed for that recursive formula. So just plug in some, if you wanted to find the 10th term, I'll just write it up here. If you wanted to find the 10th term, you would need the 8th term, 10 minus 2, plus the 9th term in order to find the 10th term. Okay, but that's recursive. We'll spend more time on that next week. Look at the example here. The number of chairs in each row of an auditorium follows the pattern 2, 5, 8, 11, 14, 17, 20, and so on. Can you develop a formula for this sequence? Okay, so here's the recursive formula like we just talked about. The first term is 2. It's given to you. And then you can give a formula like this saying that we're going to add 3 plus the previous term to get each term. So that would be the recursive formula for that problem. But here you can see that you're adding 3 each time. So this is what we call arithmetic, like we talked about earlier. If you look down here, there's a definition for arithmetic. It says the sequence is arithmetic if there's a constant d for which a term is the previous term plus d each time. Okay, so d is known as the common difference. This is the formula for d. A term minus the previous term. So if you look up here, 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3, and so on. So this is the formula that we will use for arithmetic. If you skip down here, the nth term is the first term plus d times n minus 1. Another way of looking at that, if you don't know the first term, you can just say that a sub n equals a sub m plus d times n minus m. So if you look up here, the reason we subtract 1 is because this is the first term. If I only knew the 5th term, then I would just plug in the 5th term there, but I would subtract 5 in my formula. Also, it's really important that you notice that this is linear. Okay, so when your formula is linear, your d would be your slope. That just means that you're dealing with an arithmetic. Okay, so for this one up here, we would just say a sub n equals the first term plus 3 to the n minus 1. If you wanted to simplify that, you could. What would that be? 3n minus 1. So that would be an explicit formula for that sequence. All right, flip it over. Let's look at example 2. Note which sequences are arithmetic. For each arithmetic sequence, name the common difference. Is this one arithmetic? Yes, it's adding 3 every time, so we would say d equals 3. Is B arithmetic? Let's see, it's adding 1, then it's adding 2, then it's adding 3, so that one is not arithmetic. The next one, subtracting 8, subtracting 8, subtracting 8. So we would say yes, it is, and D is a negative 8. D, is this one arithmetic? It's adding, looks like it's adding 0.6 every time, so yes. D is 0.6. Now again, don't forget the formula is to find D, Because if you're dealing with some strange numbers that you can't tell just by looking at it, maybe you're dealing with fractions. If I take 9.9 and subtract 9.3, I get 0.6. Then if I take 10.5 and subtract 9.9, I get 0.6. So that's the formula to find D if you can't tell just by looking at it. Look at example 3. Go back to letter A above, write the general formula for the sequence and use it to find the 102nd term. Okay, so the formula we would say is nth term is equal to first term plus D to the n minus 1. So if we want to find the 102nd term, we would say 10 plus 3, 102 minus 1. (10 plus 303) or 313. That would be the 102nd term of that sequence. Much quicker to use the formula than adding 102 terms there. Or not adding, but adding 102 times to come up with the 102nd term. All right, if you look at the next one, we'll use the other formula. Not really the other formula, but the other version of that arithmetic formula, which was the nth term is a sub m plus d times n minus m. Because this one gives us the 32nd term and it gives us the 45th term. And it's asking for the first 3 terms. So the first thing here is we want to find D. Okay, we have the 45th term and the 32nd term. We just need to find D. So what I'll do is I'll say that the 45th term is 142. I'll let that be the nth term. And then I'll let 103 be a sub m. Solving for D, my n was 45. That's the nth term. The nth term is 142, but the number of the term was 42. I'm sorry, 45, not 42. Minus my m was 32. Let's see, subtract 103 and I get 39. So D is equal to 3. Now, once I know D, I can go back and I can find the first term. Let's see, we can use, let's just use the 32nd term. That'll be good. We can say 103. Now this time I'm just going to go back to that original formula since we're trying to find the first term. I'll use that formula there. We'll solve for a sub 1, first term. We know that my D is 3. We found that right here. And then let's see, we used 103, which is the 32nd term. So we'll do that right there. So this is 103 equals first term plus 3 times 31 is 93. and then we could subtract that, and we get 10 is the first term. So first three terms would be 10, 13, and 16. First three terms of that sequence. So that's basically everything you need to know about arithmetic sequences. There's kind of a random topic that I need to talk about just because time allows us to bring it up. It's going to show up in some formulas and stuff next week. We need to talk about factorials. Let's see here. For a positive integer n factorial is defined as n exclamation point. So that's the symbol that we use for factorial. It just means that you would take n, multiply it by the previous term, multiply that by the previous term, or the previous number, I shouldn't say term. So, and you just keep going all the way down to 1. Okay, so for example, 4 factorial would be 4 times 3 times 2 times 1, which is 24. That's how you use factorials. Now, random note, it's one of those deals, kind of like any number to the 0 power equals 1. That's just an easy way to remember it. But 0 factorial is always 1. All right. So look at this example. Write out the first 5 terms for nth term is equal to n factorial minus 1. So first term would be 1 factorial minus 1. 1 factorial is 1. Second term would be 2 factorial minus 1. So that would be like 2 times 1. That's 2 factorial minus 1. Third term, 3 factorial minus 1, which would be 3 times 2 times 1 minus 1. So you get 5. Let's see. Fourth term. Would be 4 factorial, which we already found that. 4 factorial minus 1, so that'd be 23. And then fifth term, 5 factorial minus 1. So that would be 5 times 4 times 3 times 2 times 1. So that's 120 minus 1. So 119. So first 5 terms of this sequence would be 0, 1, 5, 23, and 119. That's how factorials work. And like I said, you'll see some formulas later on which will deal with factorials. All right. There's some other examples down here. I'll skip example 6. You can plug in a 1, plug in a 2, plug in a 3. Write an expression for example 7. Let's see, if I plug in a 1, if I plug in a 2, I get 1/4. If I plug in a 3, I get 1/9. So that would just be 1 over n squared. Again, if I plug in a 1, I got 1. If I plug in it, and this is my n. If I plug in a 2, I got 4, and so on. Well, there's the bell, so I have to stop teaching, but I hope these notes helped you out. Here's your assignment there at the bottom. Enjoy, and I will see you tomorrow. Thank you.